Hello and welcome to R&D Mathematics. Today we are going to talk about again graphing techniques, but we have already completed all the techniques. Now today we are going to combine everything, so combination of all the techniques that we learned today and some problems. So let's see, let's start with example. F of x plus 1 squared minus 2. This is a simple example. So now I would recommend you to pause the video and try yourself. So what you need to do here, break down steps, like what is the base function, we are going to use here. The base function is actually x squared, so you start with x squared. That is the first step. Identify your base function. It looks like this. So if I were you, what I would do, x squared, this is the let me write down breakdown of this particular problem, right, of our first problem. Then I would draw x plus 1 squared. Then finally I would minus 2. So from here to here, what transformation can you guys remember? So it has this form, fx plus c form. So one unit to the right, and from here to here it has actually fx plus or minus c form, right? So two down. Let me write it like that. Now we are actually basically done, right? So the first step, one right. Oh, I'm sorry, I'm making a mistake here. Not one to the right, one left. When you have plus, it is left. So please watch my earlier 3 videos if you can't remember these steps. So one unit to the left. So here our vertex, this point will come here now. So like that. And then we have, so here one left and here two down. So 1 2 like that, right? Now this point originally 0, 0, and now this point is 0, no, what, negative 1, 2. Negative 1, negative 2. Actually, there is a nice combination, a nice relationship between where the vertex change. Actually, I mean, in a quadratic function, where your vertex change in transformation new point, and if you see these numbers right here. But we'll talk about in detail about those things when we are dealing with quadratic functions later. For this lesson, you just need to transform starting with the base function. Let's see more examples. How about this? F of x equal minus 2 times x minus 3 squared. Okay, again pause the video and try. Assuming you have tried, breakdown. So if I were you, see, this breakdown may not, let me go to the previous ones. This was my breakdown. Somebody else could have done this breakdown, x squared minus 2, and then you replace that by this. Still it's correct. So in that case, what's happening here, first 2 down, and then here, so in this step right here 2 down, and right here 1 left. Still correct, right? So still you will end up here, but the middle position would be different. Now let me draw this. So if you go in this path, what will happen here? This graph will come and 1, 2 down. And then from there, 1 left, and you get to the same graph, right? So breakdown is not unique for person to person. Now, if I were you, this is how would I break down. Sometimes even though you can go around with different steps, sometimes it's easy, there are easy paths. So let me see. So first step, x squared, that's what I would do. Then I would do x minus 3 squared. For me, it seems easy. Then then 2 times x minus 3 squared. Finally, just add in a minus sign, it will flip, rotate around x-axis. So here, let me use another color. So here, 3 right. From here to here, you have 2. So what you're going to vertical stretch, right? So vertical stretch by a factor 2. And then finally from here to here, you are just adding minus signs. So reflection, upside down, reflection about x-axis. Now let's draw this thing. So x squared, next step would be 3 right, so 1, 2, 3, like that. And next step would be vertical stretch, so 1, 2, 3. You know what, when you are doing a vertical stretch, it's nice to draw your earlier one with dotted lines and the new one. So now it looks nice and people can understand. And then from there to there, what you need, so 1, 2, 3, upside down, and that's it. Okay, next example. How about this? F of x minus 2 plus 4. Again, pause the video, try it yourself. Okay, here's what my solution. I would like to draw this, and then I would like to go with this. So here to here, 2 right, and then finally add 4, so 4 up. That was not that hard. So x, it looks like absolute value of x, it looks like this. And then you have, so 1, 2 to the right. This is x minus 2. And then you have finally what you need, 4 up. So 1, 2, 1, 2, 3, 4. It will go here, right here. So that's our f of x. I think actually you understand what's happening right now. Let's see a little bit challenging one. How about now let me break down. How about this? X minus 2. What do you think? Okay, so the breakdown. First step, I will draw this. This is not challenging, actually this is easy. Second step, inside this. So what will happen? Again, see guys, fx minus c. This is what's happening here. So here, you have to be careful. Here, 2 right. So you start with this. And 2 right. So this is root x. And here on 2 like this. So this is f of x, the given function. And if you check the domain, x minus 2 must be greater than or equal to 0. So x has to be greater than or equal to 0, which makes sense. If you project it down to the x-axis, see, you are getting this as the domain. So we are good. Okay, last example. Let's see this. Now, 2 minus x plus 1. I really want you to try this because this is little tricky. This can be a little tricky, and I want you to try this. Now just try it, and as a hint, after you are done, try to think about this domain. It can be helpful. Whatever your graph, easily you can find the domain, and then using this part you can find the domain. Inside it has to be positive, right? So this is how I would break down this. This is a little bit tricky. First x, then I would actually, this breakdown comes from this observation. 2 minus x actually minus x minus 2. Do you agree? So when I take a minus sign out, it becomes minus x minus 2, because minus into x, that's minus x, minus into minus 2, that's plus 2. So minus x plus 2, when you rearrange, it's 2 minus x, right? So what I would do, next step minus x minus 2, and finally minus x minus 2 plus 1. This is my breakdown. So from here to here, it is reflect about y-axis this time, because this is f of negative x. It's in my second part video of transformations, and from here to here it's f of x minus c type. So what will happen is 2 to the right, 2 right, and finally from here to here 1 up. So let me draw it over here. So you start with here, and it will flip around y-axis, so here to here, and then from here to here you will have 2 right, so 1 2 to the right like this, and from here to here finally you will have 1 up, so 1 2 1. This is the point, new vertex. It looks like this. So our domain is actually, when you project it down to x-axis, this part is the domain according to the picture, according to the graph. So the domain of function looks like negative infinity all the way up to 2. And also the range, using the function range of f is the, when you project it towards y-axis, what y values it covers. So all the way from here, so range is 1 to infinity. Now let's talk about domain for a second. Let me erase this breakdown part because I need some space. Now domain, you can find domain actually using this part, right? Take that radicand sign, make it greater than 0, and when I take x to the other side, x is less than 2. Oh, see, if I make it like this, negative infinity to 1. Now this is a little tricky one. Were you able to get this right answer, or did you get something like this, or did you end up having something like this? So this is a little bit tricky, and there are a lot of places to think about, and if you have concerns about that, please make a comment. And I believe that's enough examples for transformations. And in our next video, what we are going to do actually operations of functions. Okay, thank you.